And today we're talking about the coordinate plane. Now, let's start off by saying what is a plane? And I don't mean an airplane that goes, ooh, it flies in the air. We're talking about a plane where that's described as a flat surface that goes in all directions forever. And it's just a flat surface that extends in all directions. It's important in mathematics that when we talk about a coordinate plane, and we just can't just set down a grid line anywhere, we have to have a place to put it. So thus, we have a plane. So that's abstract because you have to think about a plane when you're imagining something that you don't have a visual to see. So a coordinate plane is a grid line on top of this flat surface that goes in all directions. The one thing you need to know when we talk about a coordinate plane is an ordered pair. An ordered pair is the relationship between x and y on the coordinate plane, which I'll show you in a second. But the first thing I want you to realize is the ordered pair is written with parentheses x comma y, where the x coordinate, oops, let's move that, my basketball thing, where the x coordinate always comes first and then the y coordinate comes second. That's the ordered pair, and that's the way you have to follow suit. Y never comes first. It's always x coordinate, then the y coordinate. Okay, so let's move on. So you'll see what I want you to do is to draw right now. Now I don't have all the grid boxes in that I'll have when we get back to the classroom for this with the smartboard. But right now you could just draw two perpendicular lines that intersect perpendicularly and label the one that's horizontal the x-axis and the one that's vertical is the y-axis. Now for right now, for our purposes, everything is in units of 1. But you can set up and count by 2s if you want, where we start with 0, always in the middle of where the two line x and y axes meet, has a special name. That's the origin. The origin. O-R-I-G-I-N. That is the coordinate point 0, 0. That is where the x and the y axes meet and make perpendicular lines, which give you 4 right angles. So we have, but everything is in units of 1 right now. The positive numbers are to the right on the horizontal line for the x-axis, and to the left on the x-axis are the negative numbers, and 0's in the middle. On the y-axis, the positive numbers are above, so think of a thermometer, and the negative numbers are below where the intersection is, the origin. Now there are 4 quadrants that are created by the intersection of the two axes. The first one, and I always, in the old days, quadrant, they're all called quadrants, but it was called with Roman numerals, and I'm still use Roman numerals. You don't have to, you can use the number 1. But it's important to recognize what the x and y coordinates values are in that quadrant. So the coordinates are always in quadrant 1, x is always going to be positive, and y is always going to be positive in quadrant 1. So the coordinates, if I give you a coordinate with 3, 4, the coordinates 3, 4, you should be able to tell me immediately it's in quadrant 1, because x is positive and y is positive. So to show you, we would go, if I gave you the point 3, 4, coordinates of the point 3, 4, you would go, start at 0 at the origin, you would go on the x-axis first, you would go over 3, 1, 2, 3, and up 4, 1, 2, 3, 4, and you'd mark your point there. Okay? You would also label it. You always label anything you put on a coordinate plane so someone else can follow your work. Now, when we're naming the quadrants, they go counterclockwise. So the next quadrant is to the left of the top of the y-axis, and it's quadrant 2. And again, I use Roman numerals because that's the way I learned, but you can use the number 2 as well. In this quadrant, the x and y coordinates are, well, what's the x coordinate? Always in quadrant 2 to be in this. It's going to be negative, a negative value. And what's the y coordinate going to be in this quadrant? It's going to be positive. So this one has to be, as we're moving counterclockwise, then we're in the bottom left. And what quadrant do you think that's called? Yeah, quadrant 3. So we had quadrant 3. Again, I use Roman numerals. You don't have to. And what's the x coordinates? What's the x coordinate when you have a point in the third quadrant? It's negative. And what's the y value? It's negative also. So if I give you the coordinates of a point and they're both negative, and I say, where is this located? You should be able to tell me immediately it's in quadrant 3. And as we finish, we have quadrant 4. And again, now what is the value of the x in this, the x coordinate in this point? It's going to be positive, and the y is going to be negative. So now you have an idea of the layout of a coordinate plane. You have the x-axis and y-axis. Now, if I ask you to tell me where a point is, what do you do if I tell you the point is right here? What quadrant is it in? It's not in a quadrant. It's on the x-axis. The point would be when x is 4, y is 0. When x is 4, y is 0. It lies, so it's not in a quadrant. And you wouldn't say it's between two quadrants. You would say it's located on the x-axis. The same thing if it's on the y-axis. If I put a point here, when x is 0, y is -1, what quadrant is that in? It's not in a quadrant. It's on the y-axis. So you have to remember that. You don't say it's in between. It's on the axis. Okay. So now, what do we do with a coordinate plane? Well, we've been talking about equations with one step, and now we're going to introduce a second variable. And we're going to say that ordered pairs represent solutions to linear equations. What's a linear equation? A linear equation is a graph of a straight line. It's always the exponent. Well, the exponents are always to the first power. That's really important that you're able to recognize this x is to the first power, the exponent, and the y is to the first power. So this is a linear equation. That means my graph needs to be a straight line. That means any ordered pair, a value for x and a value for y, is going to give me a solution to that equation. So you have to graph it. So that there's many, and I hope you can see that whenever I plug into an x, whatever value I pick for x, I can pick anything I want to. I can find out what y is and vice versa. But, I'm just going to stick with x because it's being the coefficient of x is 2. So if I said x is 100, then 2 times 100 is 200, and 200 minus what will give me 1? 199. So when x is 100, y is 199. That is an ordered pair. And if I had that ability to graph it, that would be on the line that I'm going to show you in a second. That would be one of the solutions to this equation. So to do that, we don't need to pick large numbers because we just need to set the pattern of the linear equation. So I like to make a t-table where I put values for x and y. You don't have to show any work. You're going to like this. You can do this mentally. I like you to pick it first. I know the shortest distance between 2 points is a straight line, so you should only need, theoretically, 2 points. But I like you to practice plugging in values for x to solve for y, so I'm going to make you pick 5 points. And I'd like you to get a couple of negatives and a couple of positives. And you'll use different things depending. So I'm going to put the values in for x and solve for y. So when x is -2, 2 times -2 is -4. And -4 minus what number will give me 1? Right? Do you know? -5. Right. Because -4 minus a -5 will become -4 plus 5 will give me 1. So when x is -1, that becomes -2. -2 minus what number will give me 1? Minus a -3, because a -3 becomes a +3. Now this is all because of the integers. That's why we're doing this. Okay, so when x is 0, what is y? 0 minus what will give me 1? 0 minus a negative 1 will give me 1. Now, are you noticing a pattern here? Because that's what you want to start to see. As x increases by 1, y increases by 2. So the pattern is when x increases by 1, y increases by 2. So I don't even need to finish plugging these in. I can look at my pattern and know that the next number is 1 and the next number is 3. So I can check it by going 2 times 2 is 4 and 4 minus 3 is 1. Well, that's true. Now these are all representations of ordered pairs that we're going to plot over here to show the solution of the line 2x minus y equals 1, to show all the possible solutions for that, because there's an infinite number. Notice I put parentheses around that because that's my points. Now it kind of gets messy to stick in all those numbers. As I told you, you have to identify, you have to label anything. So what I like to do is I like to make them points, A, B, C, D, E. Now I'm going to plot these points, and instead of putting -2, -5 on this graph, I'm going to plug in an A that represents that. So I come over here and I go, when x is -2, y is -5. 1, 2, 3, 4, 5. And it's A. When x is -1, y is -3. And that's B. When x is 0, y is -1. When x is 1, y is 1. And when x is 2, y is 3. Now, we have to connect the dots, and we have to draw a line. So, you know, you don't have to be perfect. You just want to do a rough sketch through it. And notice I put arrows on each end because this is telling you that the solutions go on infinite y, and anything that falls on this line will be an ordered pair that is a solution to the equation 2x minus y equals 1. And therefore, we must take the equation 2x minus y equals 1 and we must label our graph so that someone who's looking at that recognizes that this is the solution set of all the ordered pairs that will make 2x minus y equals 1 a true statement. So anything that lies on this line is a solution to that equation. So now what I want you to do is I want you to try, and you can just draw a rough sketch of an x and y axis and plug in some points, and I want you to graph y equals 4 minus x. All right, stop the video, and when you get it going, come back and we'll check it. Welcome back. Let's see how you did. Okay, notice the one thing I forgot to do is I forgot to label my what? My points with the letters. I did graph everything, and notice I put y equals 4 minus x. Did you do that? This represents the solution. That's an arrow. So let me plug in my points. So when x is -2, y is 6. So that's A, B, C, D, E. So now I've labeled all my points. I got my equation labeled. I've got my solution set. All right, so now I want you to write down 2 things that you learned and 1 question that you might still have. We use this a lot to show graphs of any kind of businesses, profit loss, statements, growth of a company, customer base, all kinds of things. So write down 2 things that you learned and 1 question you still have, and I'll see you tomorrow. Oh, but first, what's that? Oh yeah, I know. I told you guys I'd tell you about the story about coaches. So when I was coaching and I was not married, my main name was Johansson, and I was Coach Johansson. And one of the kids one day made a comment about Kojo, because at the time there was this wacky, ferocious dog movie out called Cujos, and they were teasing me, and they called me, it was Kojo, you know, because I was so a fiery basketball coach. So I kind of like Kojo. And my goal then became that someday when I retire, I'd like to live near a beach and have a taco stand. And what perfect way than to call it Kojo's Tacos. I thought that was catchy. Kojo's Tacos, and I'll just relax every day and go to the beach and sell tacos and just enjoy my rest of my life. So that's going to be a while before I retire. So I like the little nickname Kojo's. So a couple of years ago when I started these videos, kids said, "Oh, you need to name your videos." So I said, Kojo's. I like Kojo's. So it's now Kojo's Math and Kojo's Pre-Algebra. I know, it's pretty bad, huh? It's pretty corny, but you know me. Have a great night, and I'll see you in school tomorrow. Bye-bye.